neural networks. Siloshan explained well about neural networks, and I did a session on how you can deploy DeepSeek locally and use it to create your own applications. So I would like if any of you tried that from home, and if you have any question, you can ask at the end of the session. During this course, we will explain about the ways that we can create applications like that, AI applications, to find solutions for the problems that you want to address in the medical context. So mainly, I will focus on pre-trained models in high level, and Siloshan will discuss in detail about the technical part, the concepts and all, how these AI concepts work, and everything related to that. So today also, I am planning to introduce you something like that. Before going to that, I would like to see where we are now. So this is the course content that we have planned, and we came up to medical imaging and diagnostic. During that time, we introduced about tools that we can use, already the tools which are already available. But when I researched more about the tools, I found that most of the tools available in the market are very expensive, and those are mainly targeted for the medical hospitals, medical institutions, and like the organizations, not for the individuals. But anyway, I'll explain more about those tools as well. So even though we are right now not discussing about the other topics like clinical decision support, treatment planning, and all the other topics, we will cover those topics as well in future sessions. Because I thought it is better if you know more about the concepts into the deep level, and also about the existing frameworks and the tools and frameworks that we can use to create your own applications. If you learn those things, then you will be able to create your own tools. So then we don't have to worry about certain tools which are available in the market. If you can create uh, tools that you can use individually. So, however, we will address both like the tools that you can straight away use, and by using the framework, the tools that you can create. In the meantime, Siloshan will explain in more detail about the AI concepts. Right. So today I'm going to introduce a new trending concept called agentic AI. So this is actually like you can think of AI agent as a human. So human who can perform a task. So all of you know about, you might have already seen the chatbots available in the e-commerce applications. So sometimes when you go and buy something, so you have seen those chatbots. So there are chatbots like that, uh, who can support you in tracking orders, providing requested, if you want to know certain information, those agents can provide those requested information, and those agents can process the returns. So we feel like there is a human, but actually there might be agent running at the back end. So we don't see that, but those agents can handle like a human. So it is a good example. So customer support agent is a good example for a AI agent. So when we talk about agentic AI, uh, it refers to autonomous systems. So autonomous systems. So it will happen most of the time. It will happen automatically, not there shouldn't be someone to operate it. So in order to achieve a specific thing, we can create a AI agent. So this can heavily be used in the medical, in the healthcare sector. So that's why I selected this topic for you. So later in the session, I'll explain about the use cases in the healthcare domain. But before that, I'll explain you how it works. So in simple terms, mm, yeah, you can think of it as a human, but it's faster than us and always available. So yeah, let's go and see what are the benefits for a doctor of having agents. So we can cut a lot of administrative cost and administrative work. So we can use agent to generate notes, and also the agent can listen to what you speak and record and create notes, and the agents can do prior auths of calls, so then you can avoid a lot of time um, to select to select what are the approved calls, and also diagnostic in the field of diagnostics. So you already know that we can use AI, but in this case, there will be an agent who will always looking at it, listening to it, and will alert you if there is some emergency or some specific problem. It's something like that. So there might be an agent who can uh, early detect sepsis situation also. So, and also it will save a lot of your time. Uh, so if you have to do a lot of follow-ups, so you can reduce the time that you are spending for that. In the triages also, it will help a lot to identify the patients uh, with urgent needs. So by looking at the patient messages, the agent might be able to analyze those messages, and at the triage, those patients can be given the priority. So, and also it will, most of the cases, it will reduce errors also. Yeah, and also enable proactive care through early intervention of certain cases uh, by using the predictive AI agents. Okay, how agentic AI makes doctors' life easier? Uh, so if you have manually review a lot of documents, patient-related document, lab reports, and the reports, then AI agent will be able to help you in identifying the cases with high risk and also with abnormalities and all the risky situations like that, and agent will highlight those things to you. Then you can give the priority for those things, and also uh, like I mentioned before, spending the time for the calls, pre-auth calls, and um, and if there are cases that you cannot easily detect it, like if there can be chances that you miss drug rare drug interactions, so you can keep an AI agent to monitor that and detect those kind of situations. So there are a lot of use cases. I include a lot of use cases for you to think about the possible solutions using these agents. So before going to that, I'll explain you. I'm going to demonstrate you about and the AI agent that I have created, and also I will explain you on how you can create your own agent. This is I'll use a no code system framework that you can create agents by your own without writing any code. So that is the tool. The name of the tool is N8N. So if you go to that site, you can create these AI agents. So I'll show it to you in a while. So this tool let you connect apps, large language models, and the other tools like email, WhatsApp, and there are a lot of tools available that you can use in creating agents. So you can use, there are more than 600 plus integrations available. So you can use those facilities in order to create these agents. So the key feature of this tool is you don't have to write a code. So you can drag and drop nodes and create a workflow. So you can create, so you can automate a workflow. And also this is, I would say this is healthcare friendly because there are a lot of use cases related to this. And also this can be self-hosted. I didn't try it out yet. I'm using the cloud version, but I found that it can be self-hosted. That means the privacy will be there. Yeah, the most important thing is you have the ability to use all these tools, Google Sheets, Excel sheets, emails, and more apps you can integrate with this one. Okay. Okay, in this example, I'm going to use email. Email, like you, as a doctor, you will be able to send an email to your family doctor of your patient or something like that. An example related to healthcare. So anyway, this is a emailing for to send automatic email. I'm going to create this tool. So it is a very simple workflow. So you will be able to easily understand that one. Okay, when you say it is an agent, so as I told you before, it's like a human. So it has a brain, and also it will follow instruction. It has some instruction. We have to give some instructions. That means we have to define some instructions here in the tool. So anyway, as a human, it will take an input. So here, this is the input node. So when you receive an input, like the brain is processing that input, this agent might be able to, together with the instructions provided. So I'll show you it in the system. So instructions are prompts, like for any AI tool that we have discussed already, or the large language models, we have to give a prompt. So that prompt we can keep predefined prompt. In here also we can define such a prompt. So that is not the input that we are giving. So from the let's you know about large language models like ChatGPT. So in ChatGPT also we can ask a question, it will give us the output. So and also you can give a properly defined prompt. As I told you those days, like when we are giving a prompt, there's something called prompt engineering. So there is a way that we have to define it, uh, define the structure of it. So we can specify the role. So in the prompt, we can say, as an expert doctor, we are asking the tool to become the expert and help us to diagnose a patient, something like that. So that prompt we have to write. So then we define the role of this agent, and also what are the instructions it has to follow, what would be the output, and what are the constraint it has to follow, so the things like that. So that is the prompt, system prompt. So I'll show you in the tool how we define the system prompt. We can define that also. So this brain together with the instruction, the input it is getting will be processed and will give output. So this part you already know, this section. Because if you take ChatGPT, it will do the same. Brain in the sense, in this case, that is the large language model we use within the tool. So when we are using, when we are creating an agent, we have to define what is the model we are going to use. So now you know about all the large language models. So it can be ChatGPT or Claude, whatever. So that large language model, if you have a large language, if you are using a large language model like ChatGPT, you can give the input and it will process your prompt. It will use the brain and process the prompt and will give you the output. So in this case, additionally, in the below, there are three other nodes. Sorry, another node called tool. So brain is already there. Brain is the LLM, large language model. Instruction is the system prompt, and tool, this pink part, this is the tool. So not only one tool here, I mean, there are various tools that you can use. You can integrate with various tools and define different types of solutions for the problems that you have. So anyway, here there is a memory also. Memory in the sense, in ChatGPT also, you know, in your session, it keeps a history. So then in one session, when you open a chat window, you ask a question, and then again you ask another question, but it can use the history within the session. It can answer the, it can use its the history of the conversation that we had and answer our questions. So and also in ChatGPT, there is memory also that we can use. So here in the same way, we can in the agent that we are creating, we can define a memory to remember the things that we have already discussed, and using that history, it can continue the conversation. And also, in my case, I am using Gmail as the tool. So that is the difference. So if you are using ChatGPT, you can't use the tool the normal way. But when you are creating an agent, you can create an email tool. In that way, you can create as many tools you want. Okay, here, this is the snapshot that I have taken from my tool. The name of the tool is N8N. So from there, once I defined the workflow, I took this screenshot. That is also similar to what I have already explained to you. Okay, here, this is the chat message, the input. When chat messages received, that is the input, chat, the input that the user is given. And then there is this AI agent. There are three things linked to this agent. The large language model. So I have used OpenAI chat model in this case. So that is the first one. The second one is the memory. So I have created a simple memory to remember the conversation. And the third one is the Gmail. The tool I have used is the Gmail. So there is this plus button, so we can add more tools. If I want, I can send in this case, I am sending the output to Gmail. But if you want to send it to WhatsApp message also, then you can link a WhatsApp tool also here. So then there is the output. So if the email is sent, then the output will be something like the email is sent. Okay, let me show you, demonstrate the tool that I have already created, and later I'll explain uh, you how it can be created. Okay, this is the tool N8N. First of all, I'll show you how you can access the N8N cloud. This is the one. So here already I have created my space. So that's why it is redirected to this one. Otherwise, you have the website. You can read all the details. Okay. In my space, since I have already created the space, I'll open my space. So here I have created two workflows to test this. So I'll open the second one that I have created. Okay, after executing this, uh, I'll show you how to create this one step by step. Okay, let me execute this and show you how it works. So I'll open the chat from here. I'll say hi. It is executed successfully, and the output came as how can I assist you today? Okay, here there is the log. Through the log, you can see what is happening here. So as I told you, this is a simple memory. So the memory, in the memory, it keeps these details as a JSON. And this is the OpenAI chat model. I'm using ChatGPT, OpenAI chat model. And this is the input, I. Output is, hello, how I can assist you today. Okay, it will work like that. And I'll show you how this email sending part works. So I have one of the prompt that I have created. So please assume the role of an experienced interventional cardiologist with over 20 years experience. Right? So I am an emergency room physician and would like to discuss the case. So I'm discussing with this tool and going to get support from him. So I'm asking, should I get what medication should I start and what other diagnosis should I really be considering? Um, okay, and also here in this prompt, I mentioned 65-year-old male patient name John. I put his name also to the prompt. It should not be the way that we have to do, but I'm going to demonstrate how intelligent it is uh, to uh, create this. Okay, when it is processed, you can see these two nodes are processing. So this model and the AI agent works and it keeps everything in the memory. But it didn't use the mailing tool because I didn't say anything like that. I didn't ask it to send a mail. Um, okay. So the output was given like that. You know, I will give an output like this. So I want to send uh, this output uh, maybe to the family doctor of John. Yeah. So I'll ask ChatGPT, sorry, this agent to send that mail. Can you send the this result to John's family doctor? Email. I'll give my email address. Okay. So not now. It will send a mail to the mail address that I have mentioned. Okay. So I will open my email. Clinical summary for patient John. I received that mail 0 minutes ago. So just now, 8:30 p.m. Okay, in that summary, so I just mentioned the email address of the family doctor. So it took as Kalpani is the name of the doctor, and it has drafted a nice mail. Clinical summary, and this part I haven't done, so I have to include that also. Then it will print my name also here. Uh, sorry, from whom it is sending. So it is not configured. That's it is not there. So the doctor's name should be there. Um, right. Okay. So that is how it is. This tool is working. I think you got an idea what is happening in here. So what agent is doing? So agent is not like a normal large language model. So it's not just a large language model. It will do some additional work by sending an email. Mm, okay. So I'll now before going through node by node and how this is going to be created, I'll just open this and show these are the nodes. So if you open the node, you will see these inputs, output, and how it is done. This is the node of the email. So it's like that. Uh, okay, let me create a new one. So go to click on this plus button. So remember that when you go to this N8N site, you have to create an account. So it is very simple. Uh, so let me show you. This is the site. N8N.io. So when you go to this site, um, you will see the signing link. So you can go there. So I'm using 14 days trial version because you can see all the pricing information also. So, but we can use this in the industry. This is heavily used. So this can be recommended. So I think you can try it out, and if it meets your requirement, you can go for that. So here you can create, you anyway have to create your own account. So then you will be able to use this site for 14 days for free. Okay. Now let me create a new workflow by clicking on plus button. You can select workflow and create a new one. Okay, now there is this plus button, so you can add a note. So you can do AI agent. You have to select AI agent, and then here we will do nothing. We will go back to when you add an agent, the whole thing will come. So you are not going to change anything from there, but you have to add the chat model. So if you open the chat and try to execute, you won't be able to do that because there is no model linked to it. So you have to link the model. So when you click on this plus button, chat model, which is linked to chat model, so you will see there are a lot of language models that you can use. DeepSeek and Gemini. So you know most of the Olama also you know already. This is Grok. And all these chat models are there. So I'll use OpenAI chat model. So when you select OpenAI chat model, the next thing you have to do is you have to create a new credential. So I have already created, that's why it automatically came here, but I can click on create new credentials and I have to give the API key. So you know how to generate the API key from OpenAI website. OpenAI API key. So you have to go to platform OpenAI and then from there you can create a new secret key. So I will create so you just give a name and create your key. But for this, you have to pay little money for them in order to get the API key. So last time I explained it to you, and you can come to me if you have any questions related to anything. So then I can explain. Okay, I got my key copied. So let me keep it saved somewhere. Otherwise, I might. Okay. So I'm going to use that key when as the API key and then save. Okay. Now I will go back to my canvas. So now once you created it, it will automatically appear here. So now it is OpenAI account 3 because earlier I created account 2. But now I am creating the new one that I have created. Okay. And also the model, now I have already selected OpenAI model, but in OpenAI, they are providing all these models. So in a previous session, I have explained the differences also of these versions. So for the moment, I will use 4.0 version for the moment. So if you want, you can choose any version, but there are problems when you are using those models. So you have paid already for the API key. Uh, so uh, be careful about the tokens also. So we don't have to discuss about those things right now, I think. Anyway, you will be able to just to try it out. You can use one of these. And mm, yeah, if you want the higher accuracy and all, then you have to do a little bit of research and select the the model that you want. Okay, now back to canvas. And you have to select the memory also. So from this list, I will select a simple memory. Um, a simple memory stores in NH10 memory. So no credentials required. So it's a simple memory. So I have linked that memory also as a node as a part of the agent. Um, and I'll show you what happens if you don't have a memory. Open the chat and I deleted the memory. I'll say hi, my name is Mahesh. In this chat session, I mentioned my name, and now I'm asking. See, my name is Mahesha. Nice to meet you. Okay, so I'm asking now, what is my name? I'm sorry, but I don't have access. Yeah, it says it doesn't know my name. So now I will link this memory node here. Your name is Mahesha. How can I help you? Now it knows my name. So now it's aware about the history of the session. So it works fine. And then I'll link the email node. So as the tool, I'll select Gmail. Gmail tool. So just let me know if I'm too fast. I selected Gmail from here. If you couldn't see it, I'm sorry. I clicked on this plus button, which is linked to tool, and the right side there is tools column. So from there, I selected Gmail. Then Gmail tool you can find. Then click on that, and here it will show. the parameters that I have to configure. So here also I have to give the credentials, but I have already given the credentials in my workspace, so it is taken automatically. But in your case, you have to create new credentials. So click on create new credentials and select sign in with Google. Because if you are using a Gmail as a tool, then you have to sign into your Google account and you have to um, give the authority to use that the email related to your Gmail. You have to give all the privileges in order to send mail and do and to do all those things. You have to give full permission. That's why you have to sign in with your Google account. Mm. In this case, I will select. I created a test account also, like maheshakalpani@gmail.com. Um, yeah, I'll give my original account, this one, this time. Okay. When you are doing this, you have to give all the privileges. Uh, that's why I selected this account. If I selected the previous one, it will not ask again these things. So be careful when you give all the permissions. So you have to choose which Gmail you are going to use for this purpose. So when you give all the privileges, then this tool might have all the access to your email. So because of that, I'm not going to give my original one. I will select the test account that I have created. Okay, and continue. Since I have already given the access, it is not asking from me again. For the previous example, I have given my privileges. Okay, anyway, I selected my test Gmail account. And here I have to mention all the other information required. I'll the email type, I'll select plain text. Okay, to whom you are sending the email message. So normally, when if you are creating an agent, so we are not giving hard coded email um, address here. So instead, we are going to automate. So we can ask the agent to use the email address that the doctor is specifying when he is giving the prompt, or some other way, like if you want, you can keep a list of email addresses and you can ask the agent to send emails to the entire list. So that list you can keep in a Google Sheet, or you can keep it in a database, vector database or somewhere, and use the list also. But in this case, I do something like this. You can say from AI. So then we are using AI here to find the email address as the in this case as the user specified, the doctor specified. Um, so here I would say email recipient. To include that also, I use this little AI tool. You can even do it manually. So I would say email recipient. So the subject also, I'll do the same thing to the subject. The subject email, the message for the message email body. will be taken as the message. So when we are sending an email, so it will be the email body. So I have defined all the parameters needed. And also I saw that we have to specify that append N8 attribution. This it is better to disable this one. Otherwise, it will put in your email something like um, since there is an attribution like the sent by N8 and something like that. So you better to disable that option. So for that, you have to go to this adoption and select append N8 attribution. So that is not those things are not that important in like in this example. But when you do it in real world, it's better to do those kind of things as well. Okay, now I'll exit from here. Okay, I have already set it up. So mail is there, this one is there. Now you can do the same thing. The prompt, same prompt. Okay, in this prompt, I have mentioned that is the same thing. Here I have mentioned that patient name is John. So, okay. Let's put the result. I got like this, the laboratory test, medications, differential diagnosis to consider. So it doesn't need to be like exactly like this. I just created as you can understand it. So what you have to do is you have to create your own prompts, and also probably you might not get the output from AI or your large language model. Instead, you will give your findings here and just ask it to draft a mail to the doctor, something like that. Um, okay, this is a very simple example just to demonstrate, and you can do this various things and get a lot of uh, your difficult workflows done by automating and creating an agent. Okay, now we'll see whether we receive an email. See, let me save this once again. Maybe because I didn't save it. No, I just got the output, but I didn't ask my agent to send an email. So it is not in my prompt. So if you want to send an email, then you have to ask it to send an email, because I just in my prompt, I am asking about this diagnosis recommendation. So now I'll tell it to uh, can I send mail to John's. Mhm. It will send to the mail, whatever the mail that I'm sending. Sorry, I'm specifying. Oh, I didn't write the prompt properly. I'm sorry. But somehow it is created. I gave a wrong prompt, I think. But let's say, yeah, it has created, it has sent a mail. Let's see what it has written in the mail. Okay. Okay, a similar mail has been sent by the agent. Um, okay, about John. John is the patient and Kalpani is the family doctor. So it is writing a mail. Okay. Anyway, I have given a wrong prompt, but however, it is somehow gave me the output. Okay, now analyze the log. So in the log, you will find these. It's nicely categorized what is happening here, the memory and the Gmail, what is mentioned in the mail, and what is given by OpenAI chat module. Yeah, these things. Okay. Uh, so there is one more thing that I didn't mention. So here, the output node, you can link an output node because there are very complex workflows and you can do a lot of modification to this workflow. So you can format your output as well. So it is not that important in this case because my main purpose is to send an email. So if you want, you can add a node like this output node. So this one. Something. So don't worry about this part. It's not that important because our main purpose is to create the email sending agent in this case. So I'll save my model and also I will click on my agent and we'll see. I clicked on my agent because can you remember previously I mentioned here system prompts also the instructions you can provide. For that, click on this AI agent and go to adoption and system message. So in here you can specify whatever the prompt in a proper format. So there are tools also that you can generate those prompts from templates. So uh, so I am telling the chat my large language model that you are a helpful assistant. It's something like please assume the role of an experienced interventional cardiologist is something like that. Then the role is defined. So when I'll do another session on how to write prompts like that. So in the prompt you can define those kind of things. Then you will get a better output. So we will in this example we just got the output, but we can format format it properly like that. And the output also, we can ask it to give it in a proper format. And there are many things that we have to consider when in the prompt engineering, when you are creating prompts. So you can change this one. So I'm not going to change it now. That is what I have mentioned in here as in my slides as instructions. So, okay. Uh, and I found that in Google, also Google is also providing something like NA10, but I didn't do any experiment on it. So it earlier there was something like that. Now it has changed a lot. So I'll study that one also, and I'll share with you what I find. And here also I'll try this out with some other examples also. Whatever I do, I'll share with you. And let me quickly go back to, now the time is 9 o'clock. Quickly go back to my slides and explain you these use cases that I have put. Then you can get an idea on how we can use it in the day-to-day problems to handle the day-to-day problems you are facing. So as the autonomous diagnostic assistant, you can use this one. So you should be able to think about now you know how we can create an agent. So how you have to think how we can apply uh, it to these problems. There will be a lot of tools which helps in these cases. I'll also do a study and will come back to you with my findings. But at the same time, I would like if you can go through those things and try to find solutions for these problems. So autonomous diagnostic assistant. So in this case, like the examples that I have done before using ChatGPT, OpenAI, API, and also DeepSeek, locally deployed model. Here also you will be able to use, but in this case also the same thing is happening. You are not going to create a model or train a model. Instead, you are going to use a pre-trained model. There are various models that you can use. So you have to find a matching one to your problem. So if it is healthcare related, then since it is related to healthcare, then if you are selecting a model, then that model should be trained on healthcare data. As Siloshan explained once. So we should be able to choose the right model as well. So it depends on the data that you have trained. It has been trained on. Okay, so analyze the patient data. It's a similar example that I have taken before. So lab result, medical imaging, and patient history. Uh, like patient-related data, you can keep AI agent to analyze this data and suggest different diagnoses with the confidence score. So there are some existing tool also. In a future session, I'll show it to you, but I can't recommend that tool. That's why I am not going to not. I didn't give the priority for that. But I'll show a similar tool. Then you can get an idea on how will it look like. So we can use for this purpose as a diagnostic assistant, not to diagnose a patient. So it will recognize early signs in situations like sepsis situations by going through these lab reports, note, and patient history. So if there is an agent, you don't have to worry about it. So you just have to feed the input and it will do the analysis part and will come back to you, will alert you if there is a problem. In all these cases, it will be something like that. So you don't have to always be available by executing by giving your input and monitoring what is happening. So you can automate that one. Okay. The other one is AI-powered clinical decision support. In the clinical area, also you can use a lot of AI tools. So it's a good use case. So not only agents, so there are some other AI tools that you can use in decision support. I will do about clinical decision support later, but related to agents. So real-time treatment recommendations based on the latest guidelines, patient history, and drug interactions. So yeah, uh, in the in this area also you can use agents. So you have to think of how we can do that. So automated medical note generation. AI can listen to patient conversations. In this case, can record the conversations also and generate structured notes. So it will reduce the time that you take to type and do the documentation during the sessions. And also patient monitoring agents. So I think this is a really good use case because patient monitoring is also not an easy task. So if there are agents who can track high risk patients by analyzing their conditions, somehow you have to link those inputs to your tool, then the agent will analyze those things and will detect the problems at early stages and will alert the doctors. So alerting doctors is not a problem for an agent, as I shown you now. So you can link it as you want to any tool and get the alerts. And radiology and image analysis also, it is very good if we can early detect if there is abnormality in the medical imaging. Then we can have autonomous agent to monitor those things. So, and if we detect anything abnormal, then we can give the priority for that patient. And also personalized treatment planning. This is one of the trending area in the future, personalized treatments. So it is not happening right now that much. But since AI, now we have AI solutions, so we will be able to analyze specific stuff of the patient using patient data and do adjustment for the specific cases. And at the patient triage also, at the ER department, the systems I know, there are systems like uh, we can use AI systems to prioritize those kind of patients who need immediate attention. So we can use AI chatbots, for example, for the patients who are coming to ER, so can share the information, the patient symptoms and all, and then there can be agents who can analyze these information without having with less human intervention. The agents might be able to give the alerts. These patients have been given the highest priority, and then uh, the doctors can give the immediate attention to them. And also autonomous literature review and research. This also related to the I have shown you before that there are a lot of medical journals, lot of knowledge out there in the publicly available, and those things also you can use in efficient way. With evidence-based insights, you can get the outputs by using a autonomous agent. And drug interaction, allergy alert systems, chronic disease management. Bedside rounding assistant is something like in the boards. If you are going to the boards, then you can have a wearable like your badge kind of thing, which is listening to the patient's. When patient talks, it can listen and you can bring it and give it to an agent, and agent will be able to give some insights, findings, and it will agents can help as assistant, bedside assistants as well. Yeah. So I think you can go through these things and you can find, now all the most of the large language models that you can get the support from there. Also, you can find these use cases because some of them I found using AI tools. Some examples also. So you can do the same and you will be able to come up with some nice use cases, is the nice cases that we can apply agents. So if you let me know, I'll also be able to help you in creating the solutions for those things. That's all from my side for today. I think, Siloshan, I took 10 minutes from you. Thank you very much for everyone.
Thank
You
you.
can, yeah. I don't know whether these kind of stuff is useful for you. Let me know, then I'll be able to change the things that I'm going to include in the.
No, I think that is important. That's good to have mentioned. So it's a new aspect where we can use that.
Yeah.
Good session, actually.
Thank you. Siloshan?
Can you hear me?
Yeah.
Okay, wonderful. Okay, so let me share my screen first. Okay, so can you see my screen?
Yeah, we can
Yes.
see.
Yes.
Okay, wonderful, wonderful, wonderful. Okay. So, in the today lecture, we have I listed some another area to discuss. Before I move to that part, I would like to ask one question from the all the participants, right? So let me try to. Hold on for a second. Okay, so can you see my screen?
Yes.
Okay, wonderful. Okay, so I would like to ask from you guys that so we did around 6 lectures, right? 6, so maybe 7. I'm not sure. Maybe 6 or something, 5 or 6 lectures. So what are the keywords you have learned so far? Can you write down in the chat if you remember any kind of keyword? Maybe the AI, maybe the DL. Large language model, interesting. Neural network, great. AI, chatbot, ChatGPT, and other platforms, yeah. Agentic AI, yeah. Generative AI, LLM models, agent, deep learning, ML, neural network, CNN. Yeah, a lot of keyword. Okay. So, so reason why I am asking this question. Okay. So, usually, you are in the medical domain, right? But the sum of the stuff what we are discussing here is for some cases we are showing some technical side of things, and some cases we are showing some are related to the engineering side. So we really wanted to understand whether you get some point from our lectures, because it is that it is very difficult to explain the AI related stuff without the technical side, right? So that's why I asked that question. It is really helpful us to when we create the lectures, when we create some maybe uh, some activities. So knowing whether you are getting some sort of things from the lectures is very helpful. So that we can create our lectures accordingly, right? Okay. So look like you got a lot of keywords. Another thing what we're expecting from doing these lectures is that giving you some, I mean, if you are able to increase your vocabulary about the AI related keywords, that is the other thing what we need to achieve, right? So it is happy that you have a lot of stuff. Maybe you got those keywords from our lectures, or maybe some other sources. I don't, it is not matter, but having that vocabulary or increasing the vocabulary is important in uh, if you are going to challenge with the AI in your domain, right? Okay. So let's start our lecture series, and also uh, so if you look at my screen, in my lectures, I basically trying to cover some theoretical part plus little bit of what do you call practical sessions, right? That is how I usually create in my lectures. So we have discussed about some machine learning basic and some practical in the previous sessions, and also we discussed about some deep learning techniques, right? And also in the last lecture we have discussed the neural network, right? So today lecture is about convolutional neural network, right? So I'm not sure the name. Someone has typed the keyword CNN keyword as well. I believe that we have discussed when we do some introduction, but we did not dive deep about the convolutional neural network. But today we are going to deep dive about what is convolutional network and how and what are the other theoretical parts, right? So uh, this is kind of an complex story. What I'm going, this is so the idea is that this theory is bit kind of a complex, but I'm trying to cover this short and sweet, and as well as since your domain is not the technical domain, so I'm just trying to show some visually how it is happening. So engage with the session and don't miss any part, so that otherwise you will not get a better understanding about what is convolutional neural network, right? Okay. So in the previous lectures we discussed about AI, then ML and deep learning, right? So machine learning is kind of a very simple training things. So we discuss a lot of algorithm. Then deep learning is a subset of the machine learning. So in the last week, we discussed the neural network, right? So the neural network, if so, okay, so we in the last lecture we discussed about we have a kind of an input layer, then we have some hidden layers, then we have output layer. Those are interconnected, so we call this as a kind of a neural network, right? So if we use one or very little number of hidden layers in the neural network, neural network, we usually place that kind of machine learning models inside this area because that is a simple kind of machine learning algorithms, right? There are a lot of, I'm just trying to tell that simply, right? But when it comes to the deep learning, we will have multi-layers neural network, right? Multi-layers hidden. So let's say, so in the, we said that we have input layer, then we have kind of an hidden layers, and then we have the output layers. But if we have multiple layers as a hidden layers, we usually know that like we need lot of computational power, and as well as we need lot of calculation, a lot of effort to train the things, the thing. So we, since we have the multi layers in this network, we keep this kind of algorithms inside the deep learning, uh, uh, inside the deep learning, right? So now you should be able to understand if the neural network is very small, or maybe one, either maybe the one or two layers, so we can keep that as a machine learning. But if the neural network is like if it has a uh, multi layers, and if it is very complex, then we are usually putting that in under the deep learning, right? Okay, so these are the stuff we learned in the previous lectures. What is machine learning, blah, blah, blah. So I'm not going to talk about. So when we discuss this deep learning, as I said, we have three layers: input, hidden, output. But when it's come to the CNN, we already have the neural network part, but on top of that we have name called convolutional, right? So by the name you should be able to understand it is something we need to add on top of the neural network to become that algorithm as a CNN, right? So okay, so CNN is, in a simple term, we usually, when we talk about the CNN, the question we need to understand is how machines see the world, right? How machines see the world. So, so we can answer this question later, but in the real time, or in the practical scenarios, or in the nowadays, you can see that this kind of application, right? First one is face recognition application. This is very famous application, but maybe until today, you don't know how this is working, right? For some cases, you might know, there is a, once we scan the face from the camera, then camera detects some face, what do you call it, the face landmarks, where the nose is located, then where the eyes are located, where the ears are located, then where the mouth is located, where the lips is located. Likewise, based on that, it's creating a kind of a what do you call, kind of a mask. Then based on mask, it is matching with the data, right? This is what, that is the known story, right? But if we talk about the concept in depth, this is also a kind of a training methodology built from the convolutional neural network, right? Okay, so when we talk about the CNN, we have to talk about like how our what is the specialty of our brain, and what is the computer logic, right? Because we know that in the previous slide we talk about the neurons, neurons, how neurons are activating, right? So it's a concept of the concept came from the human system. Since based on that, the computer created the same way artificially. So we, for when it's come to the neural network, we call that as a artificial neural network, right? So since this is creating artificially, right? Uh, so if I ask one question like, so in the neural network, this is a sample neural network. In the neural network, we have input layer like this. But let's say when I talk about in the previous slides, I said that if you are going to train if you are going to use the neural network to train a model, you should have, let's say, so in the last time we use maybe some 28 by 28 pixel image. So what I said is we should have 28 into 28 size of input layers in the neural network if we are going to train an image this kind of, right? Maybe this is maybe okay because 28 by 28 maybe something around 400 or something, right? 400 or something. Yes, yes, 400 or something, right? So that is very simple, or maybe that is very smaller number of input, right? That is fine. So because the number of inputs nodes are very smaller, so we can use a simple neural network, right? But then the previously we used, the black and white image, right? But think about this. If you are trying to train a model using a colored image, probably the number of pixels in the image is really higher than the black and white image because in the RGB image we have 3 layers, right? So in the previous example we had 28 by 28, but if it is a color image, it has a 3 layers, so we have to multiply this by 3. So if the previously if the pixel count is 400, now it is, if it is multiplied by 3, that means 1.2k pixels or the input nodes we need to train this model, right? For some cases, this 28 by 28 is a very small image, but if you use the very higher image, so you know there are, so if you get your image captured from your mobile, it will probably take more than 1,000 pixels in one side, right? So if you get this kind of an image in the RGB, probably you need, let's say if we calculate this and this much into the 3. So this much of pixel, I mean the input node to train your model, right? So let me erase this. Okay, so this is one of the calculation I made. Okay, so this Cola image has 1.9k into 1,800 pixel into 3. So if we calculate it, the first layer need around 6 millions of input node, right? If we are planning to do neural network, right? Then with the, you know that there are a lot of hidden layers we have to create. So with all the hidden layers, if we calculate that, number of nodes we need is around 24 million, which is really high, right? Which is really high. So since this is become a challenge when we use the artificial neural network, so the the researchers started finding a method to reduce this number of pixels, right? How we can reduce the number of pixels when we use the neural network, right? So they come up with a solution to add small part on top of the neural network, which we call convolutional. It's a kind of a mathematic algorithm to reduce the pixel count. So the idea is that they tried to add a special mechanism or the special mathematical calculation using some of patterns to reduce the pixel. In the previously, what we talk about is the input should be the number of pixel which is in the image, right? They tried, instead of using this pixel as input, they tried to use some other method as a input layer. In the previously we used the pixel. If we are going to use the pixel, then we need a lot of input nodes. So they try to do some mathematical calculation to reduce this pixel, right? So if you look at this picture, this is a very simple picture. You can see that there are some, let's say as example, I put the -1 for the all the white areas, and I put just plus mark to the all the areas where we have the major shadow of the night, right? So if I check this image, you can simply see that the pattern of this highlighted pixel, right? This is the 9 here. Then if I highlighted if I mark all the activated cell, you can see a small pattern here, right? You can see a small pattern here. So if you get another variation in the 9, you can see a small pattern here like this, right? And this is the previous one. This is the new one. Also, if you look at another pattern, you can see this pattern. This is the previous pattern. This is the new pattern. There is a small similarity. So, in the neural network or the artificial neural network, if we have this kind of a simple pattern, probably we can able to use the simple neural network because of the number of pixel count is slow and the complexity of the image is lower there, right? But when it's come to the color image with more complexity, we should find a way to input the features of the image, right? Okay. So, example, see this cola image. So, in our brain, we are identifying this as a cola, maybe due to some of the features, right? Some of the features like eyes, nose, how the nose is appearing, then how the ears is appearing. Then I'm just telling that how the human brain is thinking about when classifying this as a cola. Before I explain about the CNS, the technique of the convolutional, right? This is how our brain is just thinking. The first we are thinking about the two eyes, nose, and ears and mouth. Then we categorize this is the cola set, right? Then we think about the hand. Yes, this is a kind of an cola set. Then think about the legs. Yes, this is a kind of an cola set. Then yes, this is the cola's body. So based on that, we can find, first we identified the cola set, then we identified the cola's body, Okay, this is Cola's head, then this is Cola's base, so that we can come for a conclusion that this is Cola, right? So in the convolutional part, we try to do the researchers are trying to do the same way, same application to reduce that number of the input count, right? Okay. So I put that image the same way to identify the patterns here as well. So how the brain is identifying the 9, the upper part, then the middle part, then the latter part, right? Okay. So okay. So I will take to explain this convolutional part. I will take this simple couple of examples, right? So the idea of this convolutional part is if there is an image, in the previously we used the pixel as the input. In the convolutional part, what we are doing is that we are trying to identify some specific areas. As I said in the Cola, the specific areas and eyes, nose, ears, and mouth maybe. So in the similar way, instead of inputting all the pixel to the as an input, we in the convolutional part, we try to identify some of the features, and this we are inputting this whole feature as a one input to the neural network, right? One input to the neural network. Instead of inserting pixel, we finding some portions, or we call this as a filters, right? Some filters, or based on the filters, we are identifying some of the features of the image. Then we input only that features instead of inputting the entire the pixel as an input, right? I will show an example. Okay, think about this is our image, right? This is our image, right? Then this is the feature, or this is the filter what I'm trying to match with the image, right? Think about the example, like, so in the Cola's example, I said that our brain is just first thinking about the eyes pattern, whether that eyes is matching with the, then it is checking the nose, then it is checking the leg, right? So likewise, here the network is, we can define this filter, right? We can define this filter. I am defining this filter from the numbers to match whether, think about that, this is maybe the let's say, so if the image is representing the 9, so think about that, this filter is representing this part, right? Maybe this is 9, this is representing this part, right? So I am just checking whether this part is with the matching in this image. Let's say this is a 3 by 3 image. First I am matching this part, whether this part is matching with this part. Then this is my, think about this, my the output matrix. So if it is matched, I will put a number 1. If it is not matched, I will put a 0, right? Okay, so here what I'm going to do is, first I'm matching with this one. So if it is matched, then I will put a 1. Then again, I am matching this part. If it is matched with the number, this part, I will put 1. Then otherwise, I will put 0. Then I will match this 3 by 3 matrix for this part. If it is matching, I will put 1, right? Likewise, I will compare this filter. I will applying this filter to entire image, and I'm creating another matrix, image matrix, Then I will put this matrix as an input, right? So instead of putting the pixel, I am applying some filters to the image. Based on the matching status, I am creating another pixel to input into the image, right? So let me show how it's working. So here is one, this is the image. Then I am matching this with this part, right? So I got a number. Don't think about this calculation. This is more if I started explaining this will go to the more technical manner. So just forget about this. So I'm putting a activation number here. This is the number 0.11. Then I am matching and applying this filter to the next part. So the calculation the calculation comes as 1. Then I am again applying this to the another place. Likewise, I am getting all the numbers or all the mathematical data. I will fill all the mathematical data to another matrix, right? So we call this as a feature mapped one. So this is the feature or the pattern I am searching in the mail. This is the main image or the original image. This is the filter. Then this is the features map image, right? So once we created this kind of an image, we can use this as a one input to the image, right? So when it's come to the real scenario, we are not checking only one filter. We are checking lot of filters, or maybe we are checking 15 filters we are applying to the image to create this kind of a matrix, right? So if we are adding more filters to the image, then we will get lot of input feature mapping matrix. If we add 1 or 2, maybe we are getting lot of. So if we add more filters, so that we know that we are getting lot of input, which creates the network easy to understand about the image, right? Okay, so let's say, so what I mean is that if in the collage image, what in the previously what we check is the 2 eyes, nose and mouth, right? So maybe for the eyes we have one filter, for the nose we have one filter, for the mouth we have one filter. So there are 3 filters, right? So likewise we can add another to check the chin of the cola. We can add the one filter. Maybe check the ears of the cola. We can add the one filter. Likewise, we can add a lot of filters to the network to get the feature mapped output or the matrix, right? So this workaround reduce the number of input we are putting to the neural network, right? So let me try. Okay, so this is a small video, right? I will play this video. I believe you can see this one. So this is you can see I mentioned this is the place. There are numbers in the matrix here. So you can see in the convolutional there are two two filters. We call this as a kernel. There's the same name. So the size we can define based on our understanding. Maybe you can the 3 by 3 matrix, or maybe you can get the 5 by 5 filter. So here what is going to like, so the network is first taking this filter, then matching with the entire image, then creating another matrix or the image, right? See this. Okay, so you can see likewise it is matching the entire image and creating another new image here. We call this as a features map, as I said earlier. So this is a one input. Likewise, if we have maybe the 10 filters, we can create 10 different 10 different what do you call uh, feature maps or the input features in the from the image, right? Okay. Okay. So okay. So same thing I'm trying to explain from here. So let's think about this is an image. This is the image. This is pen. Okay. So in this image, this is the metric. So just think that in the I am applying this 3 by 3 matrix to this area. When I apply to this area, you can see if I draw a box here, you can see only this part is the empty part. Otherwise, all the other areas you can see some the shadows of the night. So this filter is, you can see in this filter, this area is shadowed area and this is the empty area. So I am applying this filter to understand this whether this image has a pattern of this one, right? So the head of the 9, right? So I am applying here when so this is the 9, right? This is the 9. This is the entire image. So when I put this 3 by 3 matrix here, this might not match. But when I put this in the middle corner, this might be match, right? So that's why I put here as a 1, right? Okay. So likewise, see, likewise. So here, if we get a 6, this pattern comes in the latter part, right? This pattern comes in this case, this is coming the upper part. In the 6, this coming in the latter. So that's why I mark this one in the latter part of the feature mapped image. The same way, you can see if I match this feature map in the number to the number 8, you can see there are two areas you can say similar. That is the upper part, this part, and the latter part, right? So I put 1 in the both part, right? So if you map this style to the 96, this is if we get as the entire image. So you can see we might found match a place in this area, that is this, and you might see the matching area here, that is here, right? So likewise you can, so here I checked only this round style, right? Likewise we can create a one feature to find this part, right? This part, this curved part, right? Then we can start making another feature mapped matrix. So likewise, we can define based on your use case. You can define the filters. Then you can ask system to check the map, to check the what do you call the style or the match, whether it's a matching or not. So based on that, you can create the matrix, right? Okay. So this is a simple. This is the simple theory, which we are using when it comes to the convolutional neural network. So the filters do in this case, the filters do the main job to reduce the number of inputs in the neural network, right? So in a simple term, filters are nothing but the features detector. Okay, so as I said, if we define a feature as a filter, then filter will check all the component in the image. Then it will give the feature mapped output, whether the nose is where the location of where the feature is matching, right? So I put another couple of input while comparing the previous images to get a better understanding. Think about this is the eye detector. If this is the eye detector, then you can see in the entire image, there are two places you can see the eye. Probably in the feature map image, you can see only two areas which is match this feature, right? Then for this feature, this is the eye detector. So for compared to this image, this is in the kind of below this image, so that you can see these two images. You can see in the feature mapped image, you can see this kind of an output, right? So when it's come to when you apply the eye detector for this image, there are three colors here. You will get this kind of what do you call the features, right? This kind of the feature map, right? Okay, so this is the same thing I am showing how detect the hand. The same way, this is located in this area. So if it is matched, all the image, the output will get like this because the this hand detector is found in this area of the image, right? I listed all the steps usually we use in the convolutional when we do the convolutional part of the neural network. So in a nutshell, if we listed all the steps what we discussed so far, convolutional network, we don't feed everything the raw pixel directly into the big fully connected neural network. So the same thing what I said, we are not inserting all the pixel to neural network. Instead, we first use the filters to extract the features, right? So we use the filters to extract the features in the input image, right? In the NN, what I said is we using the all the pixel as input, but when it's come to the convolutional neural network, so we extract the features to insert to the neural network, right? And we can define the filters as we need that. We can create based on the filters what we are giving, we can create the new feature map. And each filter learn to detect a different kind of features. As I said, like we can create features to map the eyes, we can create the features to map the nose, and we can create the features to so based on that, the filter will detect the exact position of compared to the original image, whether that feature is matching to the whether it is the which place we can match in with the original image, right? So likewise, we can apply many filters, as I said. Then we can get a feature maps based on the each filter. Then we can those feature mapped the metrics we can use as an input in the neural network. So in the previously we calculated around 20 maybe in the input layer around 6 millions of neurons we needed as input. But once we apply this process, convolutional process, that will probably reduce maybe 1,000 times. Maybe we might need only maybe 1,000, 2,000 input to train the model instead of 6 million, right? So this will help to reduce the computational power of the machine when you train the image sort of neural network, right? Okay, so the same thing I put in the layer, and okay, so here I put this is the architecture of the convolutional neural network, right? Okay. So I will not going to explain this in deep manner because apart from the features, we are mapping or we are applying to the original one. We have another small steps we can apply to reduce this one, right? We can create the pooling layer. Then likewise, we can change the method we are applying the feature. So I am not going to discuss. I just explained to you the overall, I mean the high level idea, how the convolutional net how the convolutional process is working for when you are building a CNN for the image classification, right? So as I said, there are a lot of applications nowadays you can see which use the CNN. So CNN also has some lot of variations, lot of ways. I just explained mapping only the simple, creating the simple features in the image, but there are a lot of ways we can do this concept. But what you need to understand is the concept, right? The concept is, as I said, we have an image, then we have filter, then filter is mapping, checking that whether that feature is available or not. So that is the concept, right? So this feature we can define whatever the way, like based on the we can define this automatically, or when we build the neural network we can define, or we can create it automatically. We can ask AI to generate these features. There are a lot of ways, right? So I'm not discussing any of those things, but you have to get the core idea what is convolutional network, right? Okay. Okay. So I put some might and truth things right here, right? People think that AI knows everything, right? I mean when it's come to the CNN, right? AI knows everything, but truth is the CNN recognize pattern, right? Not the meaning, right? Why I'm telling that? Because the features we have to either give or we have to generate, right? Based on that, the CNN will work, right? But telling that AI knows everything is incorrect statement, right? AI learns like a human. That is also incorrect system. Why? AI need label data or supervised data. We have unsupervised. We have some other ways. But whatever the way we are giving the data, we should give a guide to model to train, right? So otherwise, AI will not learn the things, right? Okay. So okay, so that's all for today lecture, right? I believe you got some sort of understanding what is convolutional neural network, and what is how it is, what is the theory behind the convolutional neural network. So uh so okay, so before we wrap up this today's meeting or today's lecture, so do you have anything to clear about the CNN? Do you have any questions? So did you understand what the core concept of the CNN? Maybe you type on the chat, or you can unmute and tell.
So last time you discussed that artificial intelligence, that is regarding this neural, that is neural network. They are the image separation and those things based on line of separation, no? Like whether
Correct.
we decide cat or dog depending on the this line of separation. So
Correct.
here we decide them on the filters.
Filter.
So,
Correct.
we who decided these filters? We, depending on the situation, we determine the filters. So
Yeah, there are a lot of ways to the ways to define these filters. Like either you can do it from your end. These are the filters you need to match. Right? Let's say think about this use case. Let's say you are okay. So you have a face, right? Only thing you need to understand is whether the face has two eyes, right? So you don't think about the other filters. You can define a one filter which related to the eyes, right? Then you can ask system or the code to match this feature in your in the image. So you can define this. And also we have other way. We can ask system to create randomly all these features. Then the system will create the features randomly. Then it will create the feature map output.
yeah.
So good.
Thank you.
Okay, so yeah, great. It's good to you guys understand. I'm a bit impression of because for it is very difficult, as I said initially. It is very difficult to explain some sort of things without showing some maybe the technical stuff, right? So it is good to know that you guys understood the thing, right? Okay, so I actually when I create this session or the lectures, I just try to get some input from you, right? Maybe you can tell me maybe we can think about the next time we can check these answers for the question. So I would like to ask one question: why you are following this course, right? I'm not asking the answer now. We can discuss maybe the tomorrow. And also, I wanted to uh, list some of your stars, what you are doing in your medical field. Maybe based on your domain and based on your side, the activities might be changed, right? So we are not asking any confidential details. If you can give some general idea, I'm not asking to give it today. If you give some 3-4 line to us, either we can check whether when we create this our lectures to maybe the Mahisha is to doing a lot of maybe the tools which is available in the internet. So we can check based on the task or based on the daily activities you are doing, we can check whether we can get some support from the AI side to reduce that task, right? As an example, I know that this is my understanding. Okay, so I hospitalized for a dengue. I think maybe 2-3 years back, right? So what I saw is that there is a small form. I hospitalized in the private hospital. I'm just telling that the process they have followed. They are every day. They are every hour or something. They are getting some numbers of our input and output, right? Input and output, right? So what I thought is, if I'm not sure whether I'm telling about this story about with them more it's happened on 5-6 years back, right? What I'm thinking is that if we have a device, I'm just thinking, if we have a device to detect this, so people no need to stay over the night and get these numbers. Maybe when we write that number in the book, maybe it's maybe we are writing in the correct manner, maybe it's in a wrong manner. So we can get these numbers automatically, right? I'm just thinking, right? So likewise, you might have a lot of tasks, right? Daily tasks, right? So we don't know actually, right? We don't know, right? We are not the medical people. But if you list that in a general manner, either we can, when we do create the lectures on the next weeks, or maybe in the coming weeks, we can focus on some maybe the tools available in the internet, whether we can we can propose some tools. To this task, maybe you can use this kind of a tool, right? For this task, you can create this kind of a workflow. Likewise, we can help to you all to like apply AI in a practical manner to your domain, right? This is my suggestion, right? So maybe if you don't want to like list your task, it's not, it's everything up to you. If you are thinking that to apply the AI in your work, just share some sort of things so that we know these kind of the things you are doing in your job role, so that we can suggest that something. So if you follow this kind of thing, you can get a better output in an efficient way, right? Okay, so that's just a suggestion from my end. Let's discuss this further maybe next week, right? Okay, so Maisha will also agree with me. If we're having those kind of a details, it is really helpful us to get our future lectures, right? Okay, so that's all for today. So thanks everyone for joining the today's lecture. Let's meet after 1 week time then. Thanks everyone.
Thank you. Thank you. Good night.
Okay, have a good night.